Okay, this is video 1 for the object manipulation unit notes. In this unit, I want you to be able to discuss different types of manipulators. I want you to be able to discuss different types of accumulators and identify characteristics of successful accumulators. So all robots are designed with some sort of purpose. The manipulator is how the robot interacts with its environment to fulfill that designed purpose. So some types of manipulators. For competition robotics, we can classify most object manipulators into 3 basic categories: plows, scoops, and friction grabbers. So a plow is an object manipulator that applies a single force on an object without picking it up. It's the most basic kind. It's the simplest kind. In many ways, it's the easiest kind. But it's the plow. The next type is a scoop. There are many different types of scoops. This applies a force underneath of an object to elevate it. Again, there are many different types of scoops. One thing you have to worry about when you do use a scoop, you want to keep this platform underneath of the object level if you can. So you need to have some sort of pivoting knuckle here, or maybe use a linkage system of some kind. That way, as you lift it up, it stays level. Of course, when it gets lifted up, maybe you do want it to kind of tilt forward. That way, as it lifts up, the object can roll off. The third type, the friction grabbers. This basically applies a normal force between an object and a traction pad. Remember that friction is equal to a coefficient times a normal force. And that definition is very important. So what these friction grabbers do is they supply the normal force, and then they use the material to supply the friction. So if I were to take a look at a claw design, when this claw pinches on an object, it pushes in on the object. So then the normal force goes against that. If I take a look at another part of it, we got the force due to gravity pulling down on this object, so the static friction points up. And then again, we have our normal force in here. So when we go to calculate the friction, we just have to know the coefficient between the object and the claw, and times it by the normal force. So to get that normal force, then we have to have the applied force. It would be the same thing. So this friction would equal the coefficient times that applied force supplied by either a motor or some sort of elastic bands or some other mechanism like that. Another thing that may come, I don't know if it's a surprise or, no, it wouldn't be a surprise, but another thing to keep in mind is that the friction force is always perpendicular to the normal force. So here the normal force is going into the screen, and then the friction is going up relative to the screen. So they're perpendicular to each other. So under the friction grabbers, we have different classifications here. The first one here is a pinching claw. So in this one, we just have these little paddles here that provide the friction here. What's nice about it is that it can accommodate different sized objects. You just have to make sure that it opens up wide enough. When you design these, you need to have some sort of elastic give. So in this case, the rubber bands are providing some of that elastic give. If it's too rigid, you can break the parts. So for example, in this one, these little rubber paddles are providing the elastic give. There are many different designs for these. You could use some sort of linkage system to help open and close it. You could also use a worm gear to open and close it. But in all of these, you need to have some sort of elasticity to it. For these claws here, the traction pad provides elasticity. Another type that's kind of a combination of the two is a Topjaw Grabber, where we have a scoop, but then we also have this rotating jaw part that kind of acts like the friction grabber as well. You know, it uses friction to hold onto the object and uses some other contact forces. So with this Topjaw Grabber, it's got a stationary lower jaw. Attached to the top one. The bottom one provides normal force. And then the top one provides, that way you have some friction with that. But these are nice for holding onto an object, especially if your platform does not stay parallel to the floor. Another type is a rolling claw, which takes advantage of a wheel. So we got a rotating wheel that kind of pulls in a game object. These ones are nice because they require less driver skill. You just have to get close to the object and let the wheel do the rest, or pull it in. Again, with these ones, you have to have some sort of elastic give to them. So here, the elasticity is from this bendable piece of metal. For this design, it's coming from the elastic band here. But you need to have some sort of elastic give to use these objects, or these object manipulators. All right, kind of a shorter video, but that's going to conclude video 1.